If there's anything that you guys want to know, technical, you could be super crazy technical. Why discovery? There's many reasons why clients want to leverage discovery. It could be, there's a couple examples here. Eliminate the service outages. Customers having significant outages, event issues, if there's services that are going down for various reasons, and they can't get to the bottom of it. They're having problems troubleshooting. They want to remediate immediately. The first step is discovery. Discovery gives you insight into what you truly have in your data center, in your infrastructure, in your environment. Most of the time, I would say 99.9% of the time, clients are using spreadsheets or have very disparate sets of data that is collected about their environment, but it's not centralized and it's not updated regularly. So it's usually wrong, outdated. So in order to get ahead of that, they want to be able to get a single source of truth to truly understand what is in their environment, what's on an IP address, or hey, our customer portal went down. Why? Who knows? Hence discovery. So that's from an ITOM perspective. That is how discovery. That was the go-to-market that ServiceNow uses and has used for quite some time. Nowadays, discovery is used as a foundation for a lot of the other features and functionalities, advanced functions that ServiceNow has to offer. Discovery is kind of a prereq for SAM Pro, for example. Without discovery, I do not know how successfully SAM Pro would actually work, or if it would work at all, because SAM Pro goes out and leverages a lot of the information that discovery gathers about the software licensing, as an example. So the whole point is service-aware operations management. Again, as it relates to discovery, once you discover the CIs, you understand how the configuration items are configured, IP addresses, how the applications and dependencies work. All of the interdependencies from the top down are, and I don't mean this by service mapping, but something's called application dependency mapping, which is different than service mapping, which I'll touch on shortly. Application dependency mapping, which is part of the discovery process, gives you insight into how everything is interconnected, what relies on what in order for functionality to exist. So it gives the people process, how does this work, and applies that to what's in the data center. So the IT, the gentlemen, boys and girls who manage a data center just know, the server racks, and they look for blinky lights. And if a light is amber or red, that means a drive failed, they go and swap it. They have no idea what that server does, what applications are on it. And the people who use those applications have no idea what server it's on or where the rack is. So there's absolutely no connectivity as far as relationships on what it runs on which piece of infrastructure. This is the core of why discovery is accurate and consistent CMDB. If you don't have a accurate CMDB, if it's out of date, a lot of the features and functions that you see here, automation, change management, SecOps, service mapping, SAM Pro, audit compliance, automation. If the CMDB is not accurate and you go and try to run a process, let's say an orchestration process, your CMDB is not up to date, that process could fail because it's trying to orchestrate something or make a call to a specific CI that doesn't exist or has been retired. Especially when you start thinking of different data sources, these instances are hammered with different data sources. So we're ingesting information from SCCM and from Splunk and customers' homegrown application, and we have discovery. So the trick is, once we ingest all that information, making it cohesive and ensuring that data is valid. Discovery is usually used as the source of truth, and most customers will use the data that they have in SCCM or Splunk to enhance the CMDB, but they give Discovery the ability to overwrite data that was written by SCCM. So there's a data set prioritization that's usually set so Discovery will update and he will be the master of masters. So Discovery is an agentless way to actually update the CMDB. So there's nothing that needs to be pushed out to all the clients or infrastructure and network devices. It uses a multi-phased approach to actually go ahead and gather the information from your environment. And as part of that discovery process, it does, as I alluded to earlier, application to host and application to application dependencies, which is application dependency mapping. Again, not service mapping. That's different. Here's the phases that Discovery goes through when it attempts to go out and collect information from your environment. It does, the first phase is what they call the Shazam phase. That's actually what it's called. So when you go and kick off Discovery, the process is called Shazam. Shazam will go out and on your network and see which IP addresses are available, if it's alive. If it is alive and it responds, it will go ahead and take a look at which ports are open. So the IP ports that are open will help define and help Shazam understand what it is talking to. So for example, it sees port 22 open. Port 22 is SSH. Usually SSH is Unix or Linux flavor, so it's going to know that it's not Windows. It will then try to log in to the CI using the credentials that are provided on the instance. It will go through the credentials and then log in. Once it logs in, it's going to classify it, determine what type of operating system, start gathering all the information about that CI. If it's a server, the operating system. If it's a network switch or router, it will use SNMP to understand everything about that network switch, what it's connected to, what's running on it. It will then collect all the information, and in phase 3, it's going to collect all the information and then validate with the CMDB whether or not it already exists. Is it a duplicate? And if it does exist, it will update the fields that need to be updated. If it doesn't exist, it will create the CI and then it will write it to the CMDB. So the Discovery architecture, as you see here, out in that cloud over there on the left, that is the instance, ServiceNow instance. Customer firewall, behind the customer firewall is the infrastructure, as well as connectivity externally to their cloud providers, AWS, Azure, Google, as well as internal cloud, which would be VMware. The mid server itself is what does all of the heavy lifting. The mid server is what collects information and is the heart and soul of Discovery. Mid server is what does all of the discovering. Mid server is actually can be any type of Windows server. It could be Windows 10, Windows 7. It could actually be, the desktop theoretically. Mid server itself, all it is it's a executable file, the actual binaries of it. It's Java. So you install the mid server Java files on a server, and through the installation process, you connect it to the instance, and then all of a sudden now you have a mid server. Mid server is what communicates to the instance one way. So it's outbound only, 128-bit, out port 443. So there is nothing coming into the customer's environment. The mid server is communicating outbound only. So he goes and checks in fairly frequently to the instance, checking to see if there's any work to do. So when you kick off a discovery process, it goes in what they call the queue, the ECC queue. Mid server checks in and says, hey, got any work for me? Yep, you got to start discovery down this subnet. Mid server says, okay, and starts that process. Cloud discovery, as I referred to the previous slide, same thing. Mid server can reside from a connectivity standpoint. If in the customer's data center, you could have one mid server, and if that mid server has the ability to route over the network to AWS, Azure, Google Cloud, you can actually do discovery on the cloud infrastructure as well, as long as you provide the right credentials. So the mid server does not need to physically reside in the environment you're discovering. As long as you could route to it and there's no performance issues and the mid server isn't overburdened from a resource perspective, you should be fine. So a mid server can scale and has the ability to discover infrastructure and components in multiple locations just using one mid server. Okay, so here's application dependency mapping. So application dependency mapping, again, not service mapping, is what this is. Discovery will go ahead and grab information on these servers. So for example, if it was to go out and discover this Windows server, which is called v-w2k3, whatever, what he's going to do, Discovery is going to ask him, hey, give me all the information, Mr. Server. Server is going to populate the server is going to tell the instance by leveraging the mid server everything about his operating system, go in the registry to see what processes are running. Once we see what processes are running, we can determine what applications there are. So if we see SQL srv.exe running, we're going to know SQL is running. So once we know SQL is running, we're going to run additional commands, discovery commands, to get all the information from SQL. And then we will go down next and check the next process. If we see IIS running, hey, I see IIS running, that means this is a web server. Let me grab all the information from the web server. So it's going to run what they call discovery patterns. A discovery pattern is basically a recipe, for lack of a better term, of how to grab information about a specific application. So there's a SQL pattern, there's a web server pattern, Apache patterns, many different patterns. Each pattern has to do with a feature application that you would find in a data center. So we'll run a SQL pattern, we'll run an IIS pattern, and along the way, as we grab that information, we'll get information about the disk. And we will also know what port he's connected to based on the NIC. We'll grab unique identifier from the network interface. So that's how, and if we do that, if you think about doing that for this one server, and if we do that to everything in the data center, we can truly draw a application dependency map, because we'll know what relies on what, which network adapter is connected to which server, which runs this specific application. Once you actually start the process of deploying Discovery, there's a very simple guided setup for a quick install. And I'll show you this when we do the demo. Real quick, just a couple last slides and then we'll go through the demo. So when we go out and discover these applications in the CIs, discover all the interconnects, within the CMDB itself, it will actually create these upstream and downstream relationships and write them to these tables, the CMDB relation type list. So that is in the CMDB, this is how we draw the dependencies. Is contains, contained by, virtualizes by, virtualized, as you can see here. This is how the relationships are maintained within the CMDB. So we can ensure, so you can actually categorize what the dependencies are for the infrastructure. So real quick, just a couple last things before we get into the demo. This is a quick list. This isn't everything, but this kind of gives you an idea of how many different components that can be discovered. And again, all of the stuff that's listed here is out of box. You can create your own custom pattern to discover stuff that doesn't exist in the platform yet. And that's done by using patterns, the pattern function within the platform. You can create your own patterns using the pattern designer to customize the platform to be able to detect things like point of sale at Target or Walmart. If there's some specific cash registers that have their own proprietary or modified operating system and aren't running everything that would be considered out of box, you can customize or create your own pattern for Discovery to discover cash registers. Standard ports that are used is an example here. This is what's usually used. These are standard ports, nothing crazy here, but these are the ones that are leveraged by Discovery. Port 80, port 22, this is how Discovery can determine what the CI is and take that next step and then continue down that discovery process. These can be modified. So if a customer, I've never actually had to modify this, I've never had a customer say, oh, we don't use port 22. But the trick is working with a client and getting the security and networking guys all on the same page and allowing the traffic through firewalls, or there's, usually concern about, oh, you're doing discovery, that's going to flood my network. It doesn't. But the way that discovery works is it doesn't flood the network. And I'll touch on that in a minute in the demo as well, on how discovery works from a process perspective and ensures that we don't, take down the network infrastructure.
In metering the discovery ports, obviously they just predefine what ports they're going to hit. Is there a promiscuous mode so that it just literally hits everything just in a more controlled manner so that it doesn't take down the network but still hits every possible configuration that may or may not be intentional?
Yeah, so no, it doesn't. So promiscuous mode, it doesn't go out. The way it works is it's not using like an Nmap or anything crazy like that to blast. It strategically will go out, and you could meter it by limiting the amount of threads that are being used per mid server. And I'll show you that. It's pretty cool, actually. This is my instance here, used for demonstration purposes. There's nothing on here except for some dummy data from a cloud infrastructure. It's just some dummy data. Other than that, there's nothing in my CMDB, no schedules. I have 2 blank schedules with nothing in them. If we go into the mid server, so the mid server itself, everything's managed through, I only have 1 mid server. It's local mid 1. It's actually running on, this is my vCenter. So this server here in vCenter is my mid server. So he's running on my VMware mid server. And you could actually go into the mid server, and this is where you would do your modifications to your mid servers. Your configuration parameters are what you can modify to tweak and actually do some of the advanced functions of parameters as far as, this is just crazy. But in here is where you can actually begin to tweak it a little bit if you want to regulate some of the threads, connectivity, responses, proxies. That is where you would actually do your metering, right? So right off the bat, out of the box, the number of threads that the mid server uses is 25, but you could actually, I usually just up it to 35. And then, so that would be the amount of threads or simultaneous jobs that the mid server is doing. And then there's also what they call the payload. The payload is what the mid server will chunk up, for lack of a better term, and zip up and then send to the instance. So you're not going to be getting just a flurry of, information, flying from the mid server to the instance. The mid server will take that data in, ingest it, process it, package it up, send it up to the instance. So that's kind of how you would throttle or modify the behavior. I've been asked multiple times, and we've done it in multiple clients where we try to measure the amount of overhead that Discovery uses on the infrastructure, and we weren't even able to tell anything was going on.
Is there any way for a security device to feed discoveries into the Discovery server so that if there is a full vetting of a host, I can think of a developer's workstation having services that are not in a catalog turned on during their development activity, and specifically in order to avoid detection from a network monitor. And we would want something that's super promiscuous to find those things in order to try to make sure that the developer is developing in a secure and compliant way.
Right. So if a developer workstation, for example, if he's working on the network, so there has not been a time where I attempted to discover or something was there and I was unable to discover it. So, I mean, if we'll see something on the network, I mean, we need credentials, first of all. If we don't have the credentials for that workstation, we can't get in.
Okay, that makes, so this isn't actually hitting ports on a server. It's connecting to it and looking for services that.
Well, it's connecting to ports. It goes and does a port. It will go out and determine which ports are available or open, right? And then it will, depending on that port, depending on the operating system, we will log in. If it's Windows,
Okay.
Does that make sense?
Yes, it does.
Right. We're not going in and we're going in a normal way, logging in with the authentication, depending on what it is. SNMP would be for, SNMP is usually used for network gear, right? UPS, router switches, things like that. Yeah, I'll show you actually. So let's do this. So this is, again, I have no discovery. Let's set up discovery quick. So discovery schedules. First thing to do is actually to create a new schedule. Here's one that says new schedule. See if there's anything in it. Well, this pulls up. So what you need for discovery, you need credentials. So on an engagement, for example, people say, well, I always get asked, how long does it take to set up discovery and discover everything? And my answer is, how quickly can you get me all the credentials and give me a range of subnets you want me to discover? That's all I need, and a mid server. And they say, okay. And then they start trying to collect that information, and then they get pushback from security, SecOps, change control, application manager, blah, 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 blah. So it's usually never that easy, but truly that is all you need. So right now I know my IP address range. It's my home network. And let's see, in credentials, let's see what we've got for credentials. I don't think I have any in here. So let's put some in. Credentials, oh, that's Integration Hub. Discovery credentials. All right, these are just dummy ones. So I've got to put in credential for vCenter. So as you see here, what type of credentials would you like to create? Here's all the different types of credentials you could create. Usually there's 4 or 5 that you're always going to use. It's going to be VMware sometimes, but usually VMware leverages Active Directory to sign on. So it would be Windows credentials. So Windows credentials, SNMP, V2 or V3. You'll need SNMP because there are obviously going to be network devices. AWS, if AWS or Azure, if they have that. So let's put in VMware credentials. So I'm going to name this VMware creds. And the nice thing is we could test it quick before we submit it. Yep, that's my mid server, that's the port. And yes, all right, cool. All right, so there you go. That is my vCenter. And then I'm also going to need credentials for Windows. All right, submit. And then SNMP.
Does it support Vault credential management also, where
Yep.
you use a Vault?
External, yeah.
Yeah.
Yeah. That is that's not out of box. I mean, it is supported. You're always going to need a little bit of tweaking,
Okay.
obviously, because, like CyberArk and, those types of technologies require a little bit of customization, but it's absolutely supported. It's proven and vetted, and yeah, it works fine.
Okay, cool.
Yep.
CyberArk works really easy kind of out of the box, but do be aware you will have to purchase a license for the AIM agent for each mid server that needs to access the vaulted credentials.
Oh, okay. Is HashiCorp vaulting supported?
Well, anything is supported because it's software.
Okay.
So they will. I've never had ServiceNow say no. Well, mainframe isn't supported, but other than that, it's not documented. But it can you if you're good, there might be a way for you to integrate it. All right, so actually just go over here. So discovery schedules. All right, new schedule. All right, and then I'm just gonna say discover now. That's it. So I have my schedule. I have it set to active run on demand. This could be run as frequently or as infrequently as you want. Is there a best practice of how frequently? It's up to the client. Obviously, the more frequently you do it, you're going to be as up to date as possible. Sometimes, customers, depending on the environment, they'll do, one environment which doesn't change very much, on the weekends, and then they'll do nightly discovery on everything. Sometimes they'll do it on weekends only. It all depends. The only mitigating factor there is how many mid servers, because that's going to affect your architecture and how many mid servers you're going to deploy, how many you're going to cluster, and how many resources you're going to assign to those mid servers to make sure they can keep up with the workload if you're discovering a lot of CIs in a short period of time. All right, so let's go discover now. So right now, if you click on the discovery status, and oh yeah, one thing I forgot to mention, let me duplicate this, is when you roll out discovery for the first time, sometimes depending on how you want to deploy it or the customer's, if the customer only wants to discover Windows only, for example, there are ways to do that. And that is, let me get out of here. Go into, this is the guided setup. Every instance, if you type in ITOM, you can pull up the guided setup. In the guided setup, there is a section here. It says select CI data to collect. If you go to configure, this is where you can actually choose what you want Discover to discover. So you can say, I don't want in discovery, I want to turn off Unix. I want Windows. I don't want hotfix information. I want to discover storage devices. So you could actually turn on and turn off what you want to discover. So obviously with everything on, when discovery goes out and sees AIX or HPUX, it's going to discover it. If I was to disable these and it starts to do that phased process where it starts to discover what that CI is, if it sees that it's AIX or HPUX, it's just going to move on. It's not even going to waste the time to gather that information because it doesn't need to, because it's not, you have it disabled. And as you can see here, there's a lot of different options. So that is a very nice way to tweak what you want to collect right off the bat. So you don't need to do any crazy nutty options or go in and do any coding or anything. It's all just right here. All right, so let's go back to here. And let's see. Nice thing here is there's actually there's a button I just clicked. It said show discovery timeline right here. And this will show you where we're at. Remember that phases that we were talking about? Shazam. So kicked off Shazam, boop, and it looks like it found whatever 177 is. Oh, it's a Synology server. So using SNMP, it found a Synology, it's a storage device. It will use SNMP to classify it, use the horizontal pattern, and then grab information. Same with all these different CIs here, you can actually see how it actually connected. SNMP, HTTP, vCenter, and you could actually go in and let's see how. And this is where it gets fun, is once you start discovery, first time you do discovery, there's a lot of troubleshooting that needs to be done. It's always going to be something having to do with credentials, firewalls, misconfigurations of the credentials on the hosts. So one thing to keep in mind is when you're doing discovery, usually you're going to get pushback or run into a little bit of trouble with credentials on Linux or Unix, because there's a lot of concern as it relates to security. And when you tell a Linux or Unix person, hey, we're going to go do discovery, and we need local credentials, they're going to say, well, why do you need local credentials? You tell them why, because we're doing discovery and we need to be able to collect information. There's some tweaks that might need to be done to the sudoers files on the Linux boxes. All that is the reason is when we go into Linux or Unix boxes to get information about the processes that are running, in order to list those out for us to grab them, the command that is run needs to be run as an elevated privilege. So when you initially do discovery, you'll see errors, and it usually has to do with credentials on the Linux side because the user was not configured properly. So let's see how we did. So a lot of the stuff on my environment is, since I'm at home, it's gonna be like an Amazon Echo and things like that, and it's not gonna know what it is. So that's why you kind of see no results. But we do have network router. And remember I was talking about patterns earlier? A pattern is like a recipe on how to discover something. So what we did here is we used SNMP. SNMP logged in with the SNMP credentials, found out it was a network router, so it ran a pattern. If we want to see what that pattern is, we could click on the pattern and we could actually see what discovery did. So this is an actual, this is an actual log. And there's anytime discovery runs any command, it is always documented and you could see it in the instance. So this is just a very long string of things that it did in order to get the information that we gathered. As you can see here, get IP to media table, ASN number. These are all things that are done to get the information. And these patterns exist for all the different applications and operating systems. So if you ever need to understand what is going on in a pattern or troubleshoot, which is usually required depending on the issue that you're having, you'll usually come into the pattern and do what they call a debug. So if I was to click here on discovery, see there's nothing over here that says debug, but once you click on one of these sections, the discovery section, you could actually go ahead and click debug. Debug is what is used, and it's an interactive session. So if you're creating a pattern, remember how I said you could create your own pattern if you want to discover point of sale devices registers. In order to do that, it would be very helpful if there's a way to do it interactively, and this is how you would do it, is you would use your mid server, specify the host name, hit connect, and boom, this is the actual pattern designer. So each one of these, this is using the out-of-box pattern. This is where you'd go to do any modifications if necessary. So every time that you make a step or add a step, you can actually run it. So if I click there, step 18, once I click it, it's going to run all the way up to step 18, interactively go out and you can actually, it shows exactly what it's doing and what it's pulling back. As it pulls back that information, you can actually see the temporary variables. I mean, we could sit and watch this forever, but that kind of gives you an idea of the pattern designer. Let's go to the dashboard. So the Discovery dashboard will actually show you, it's a quick glance on what's going on. So it'll show you net new devices that were discovered. Nice, it's a nice roll up of a visual of what has been discovered, what has, as far as CIs, what hasn't been discovered, any unrefreshed CIs. If you go to Discovery Home, which is different than the dashboard, it'll show you what was discovered, errors, how many schedules. So this is where a Discovery admin would live and breathe, is in here. So this is kind of nice where it takes a look at the errors that are thrown and it tries to put them in a bucket. So it makes it a little bit easier to troubleshoot. So you can actually go in here, and if you see a lot of errors and they have to do with the same issue, you can either assign them to a specific person, create a task. You could actually make the changes quick and then try to do a quick retry from here. And that helps with cleaning up the errors. Credentials, let's see. Yeah, I probably did not have the right credentials for that guy. So again, credential issue easily fixed. Okay, so schedules, discovered devices. I tried to fit in as much as possible in a very short period of time. A lot of stuff I didn't cover that I wanted to would be identification and reconciliation engine, which is how data comes into the system, comes into the platform. And it's how we determine whether or not we have duplicates, as well as data set prioritization. Here you go, data sort precedences. Oop. So this is, remember earlier where I said, hey, if you're ingesting data from multiple sources, which takes precedence, this is where you would actually set that. So you can actually, as you can see here, out of the box, there's some predefined data sources, right? So you can say, all right, import set, you could set a weighted metric to it and say it applies to this table or whatever. And you can actually say, all right, I want to make sure that anything written in this table coming from this actually takes precedence. So you could actually weight the different data sources, and you could actually take it even steps further and go through and actually specify the fields. You can get as granular as fields per CI as to who gets to update which field. So for like SCCM, for example, there might be better reporting or better information on service packs or patch levels, especially when it comes to vulnerability and what data is collected from devices, network devices, for example. I had a client where we were doing discovery, but they had a very robust and advanced network infrastructure tool set, which had all the information about the operating systems and the patches that ran on all their Cisco gear. That information was way better than what we had with Discovery. So we ingested that and enhanced the CMDB using that data and use that for their vulnerability reporting as an example. Well, thank you everybody for your time. I appreciate it.